solve a design problem on batten columns. The question is, design a batten column with two channels back to back of length 8 meter to carry and factor axial load of 1000 kN. The column is hinged at both the ends. And the given data is L, that is length of 8 meters, convert it into mm, it will be 8000 mm. Then factor axial load, it is denoted by P of U, that is 1000 kilonewton. Okay, and let's begin with the solution. Let's begin with the solution. Okay, first step is assume F of CD, that is design compressive stress for a column, that is for channel back to back, that is hot rolled section, and assuming F of CD it is 135 Newton per mm square, and the formula to calculate P of U is effective area into F of C. Fine. Rearranging these terms to calculate A of E, that is E of D divided by F of CD is equals E of D is 1000 into 10 raised to 3 divided by F of CD is 135 Newton per mm square. After calculating, you will get the value of A of E as 7,407.4 mm square. Okay, now once you got the value of A of E, you have to open the steel table and in that search the area which is greater than 7,407.4 for a channel section. Okay, for a channel section. After looking that, we need to try and to ISMC 250. Why I am selecting ISMC 250? Because the area whatever is there in your steel table, that is greater than this A of E. That's why I am selecting ISMC of 250. Now next, A, that is provided area for ISMC 250 is 3867. This much area is for one ISMC. If I want to calculate for two ISMCs, then we need to multiply 2. Okay, and after multiplying it, we will get the value as 7,734 mm square. That is area provided. Fine. Now, next go to find the R of XX. That is minimum radius of gyration for channel ISMC 250 is 99.4 mm. This is for the ISMC 250. It is there in your steel table. Then once you know area provided and radius of gyration, find out the slenderness ratio, that is Kn by R calculate the F of CD. F of CD for lambda 80.48 corresponds to F of Y 250. The value of F of CD is 135.28 Newton per mm square. This value you will get it by linear interpolation. Okay. Once you got this value, find out the P of D, that is the load. P of D is nothing but area provided and actual F of CD, that is A of E into A of E, or you can take it as provided into F of CD. What is A of E? A of E is 7,734 into F of CD is 135.28. Once you calculate, you will get the value of PD as 1046.25 kilonewton, which is greater than P of U, that is 1000 kilonewton. Hence it is okay. Hence it is okay. Now this as your second step, and this one is third step. In third step, we need to find out the S. We need to find out the S distance. How we will find out the S distance? By equating I of YY and I of XX. To calculate I of YY, we are having the formula as the same formula you have to use over here, whatever I have used in earlier examples. Then I of YY, that is 219.1 into 10 raised to 4 plus 3,867. This is nothing but I of YY from your steel table, plus this is your value into 23, it's CYY distance, plus X divided by 2 into 2 times is equals 3,860.8 into 10 raised to 4 plus 3,867 into Y bar. Y bar is 0 into 2. After calculating, you will get S as 147 mm. 147 mm. Now provide S, that is distance. We have to take a more value than whatever we have got. So we will provide a 200 mm distance as a S distance. Now fourth step will be fourth step, we have to design batten. the design, we have to first take R minimum. R minimum for ISMC 250 is 23.8 mm. Okay, and there are two conditions. First one is C divided by R minimum. Okay, that should be less than this 50. This is first condition. Once you substitute over here your R minimum as 23.8, which is less than 50. After calculating, you will get the value of C, which is less than 1190 mm. That is C. This is for first condition as per your IS 800. And second condition is C divided by R minimum, that should be less than K of L divided by radius of gyration about x-axis into 0.7. We will substitute the values in this formula, that is C divided by 23.8, which is less than KL is 1 point, or you can say directly we will take this 0.7. The whole term, the whole value is 80.48. After substituting the values, we will get the value for C, which is less than 1340. Now we need to see these two values, and we have to provide a value of C which is less than, which is below than these two, Okay, so we will select a value for C. So we will select the value of C which is below these two values, is 1100 mm. Okay, and next step, that is fifth step. Fifth step is what? To design a shear. Design shear, which is coming on batten plates. Okay, and this is denoted by V of T, which is equals to 2.5% of P of U, that is ultimate load. P of U, that is factored load. Okay, so let us calculate the V of T value. V of T is equals to 2.5% into P of U is 1000 kilonewton. Okay, after calculating, you will get the value of 25 kilonewton. Once you got this value, let us find out the shear which is coming on your batten plate. Shear coming on batten plates. Shear coming on batten. That is denoted by B of B, that is equals V of T into C divided by N of S, where V and is nothing but two faces of pattern. Two faces of pattern we are going to provide. That's why the value of L will become 2. And already we have found out S, that is 200 mm, and we know the C, that is 1100 mm, and also V of T, that is 25 kilonewton. We will substitute all the values in V of V formula and we will get the answer. And the answer is 68.75 kilonewton. Okay, next step is to calculate bending, and it is denoted by M, and the formula is V of T into C into 2 times of N, where V of T is 25 kilonewton into C value is 1100 divided by 2 into N is 2. After calculating, we will get the bending moment as 6.875 in kilonewton meters. That is value of M. Okay, and next step is what? To calculate, or you can say to find out the size of battens. To find out the size of battens. In that, to calculate the size of battens, in that first thing we have to find out the effective depth of end battens. Effective depth of end battens. That is equals C of YY plus S plus C of YY. This C of YY is given in steel table and we know the S. Fine. Therefore effective depth of end battens which should not be less than C of YY is 23 plus S is 200 plus 23. That should not be less than 246 mm, and also it should not be less than 2 times the flange width of your channel. Flange width of channel. Okay, and the flange width is given in steel table, that is 80 mm for ISMC 250. Okay, and after calculation you will get the value as 160. Then it should not be less than 246 and should not be less than 160 mm. So we will take the value of effective depth as 250 mm. Effective depth as 250 mm. Now we will calculate the overall depth. That is denoted by capital D, and the overall depth will be equals 250 plus 2 times the edge distance. Edge distance. Assume Now, thickness of the batten. Next step, that is step number 9. Thickness of batten. What is the thickness of batten? That should not be less than 1/15 times of this 250 effective depth. And after calculating, we will get this value as 5.0 mm. Hence, adopt thickness of batten as 8 mm. Hence, adopt thickness of batten as 8 mm. 5 mm thickness of plates is not available in the market, so we will directly go for the 8 mm thickness of batten plate. Now, step number 10, that is check for stresses in batten. Check for stresses in batten. In that, shear stress, that is V of B divided by capital D into thickness of batten plate. Thickness of batten plate. That is equals B of B is what? 68.75. Okay. Substituting the values. Value of V of B is 68.75 into 10⁻³ overall thickness, overall depth is 320 into thickness is 8 mm. Therefore, shear stresses is equals 26.85 Newton per mm square, which is or which should be less than f of y divided by square root of 3 into 1.1 and f of y, that is 250 square root of 3 into 1.1 and the value is 131.21 Newton per mm square. With this value is greater than the 26.85 Newton per mm square. Hence, okay. Fine. Now, second step is to find out bending stress. That is equals to 6 times of moment divided by T into overall depth of the batten. 6 into M is 7 point. What is M? M is 6.8 6.875 into 10⁻⁶ divided by thickness is 8 mm and depth is 320 square. Okay, and the value is 54.93 Newton per mm square. That should be less than 1.2 f of y divided by 1.1. This is the formula. We will substitute the value per mm square. Hence, okay. Hence, okay. Now, the last step, or you can say last but the second step, is to find out the connections. In connections, that is 10th step. Use M20 bolts of grade 4.6. Now, strength in single shear. That is equals 0.78 times of pi by 4 into d square into f of ub divided by square root of 3 into gamma md. Fine. Now 0.78 into pi by 4. What is d? D is 20 mm square into f of ub is 400 square root of 3 into gamma md is from IS code book, that is 1.25. That is there in IS 800 page number 30. After calculating, we will get the single shear strength of our board as 45.27 kilonewton. Now we will find out the number of bolts required as V of B, that is shear strength, divided by strength in single shear. Strength in single shear. V of B is 68.75 divided by strength in single shear is of 45.27 kilonewton. After calculating, we will get the value of 1.5. Therefore, provide bolts of minimum 3 numbers. We will provide bolt of 3 numbers. Once we provide the bolt in 3 numbers, how your diagram will become? This is your pattern. And I will provide 3 numbers of bolts. Okay. Now, from center of the first bolt to the center of the last bolt, we will take it as 200 mm or effective depth, that is. And from center of the first bolt to the center of the second bolt is R. That is half of 200. That is half of 200. And the overall depth of the pattern is this 200 plus addition of the edge distance. That is 320 mm. Now we will check. We will apply a check. Okay. Now force in each bolt due to shear that is equals f of 1 is equals V of B divided by number of bolts. Formula to find B divided by number of volts. We know V of B and number of volts. Substituting in F of 1 formula, we will get the force due to shear in each bolt. F of 1 is equal to 68.75 divided by 3, that is equals 22.91 kilonewton. Now second check. Force in each bolt due to bending is denoted by F of 2 into M, that is moment into R into summation of R square. We know moment, what it is? 6.875 into 10 raised to 6. We know this R, that is half of the effective depth, that is 100 divided by summation square, that is 100 square plus 100 square. Now F of Q value is 34.37 into 10 raised to 3, or else you can take it as kilonewton, that is F of Q. Once you know F of 1 and F of 2, we will go for the resultant. We will go for the resultant stresses. That is denoted by F of R. F of R is equal to square root of F of 1 square plus F of 2 square. F of R is equals, what is F1 of 1? F is F1, that is 22.91 square plus 34.37 square. And the answer for F of R is equals 41.30 kilonewton, which is less than shear strength. That is 45.27 kilonewton. Hence, okay. Fine. Then we will draw a diagram. We will draw a final diagram of batten. That is design of a batten. We will first provide 2 ISMC or 250. Okay, that is back to back. Whatever I am providing over here, that are back to back ISMC 250. Now I will provide battens. These are the end battens. These are the intermediate battens. And this one is also end batten, we can see. Fine. Then we will give the dimension. Okay, intermediate pattern is having a depth of how much? How much it is having a depth of 320. This one is 250, 250 and 320 mm. And center to center distance of 110 mm. And S distance is of 200 mm. Getting it? So this is the design of your batter. Thank you.